Carbonyl compounds. What are carbonyl compounds? Compounds that has carbon double bond O as the main functional group are called carbonyl compounds. Example of these compounds are we have the alkyl slash otherwise known as aldehyde, forming something like this. And this is called RCOO, where anything that is better to this place. Some things are better to this place to differentiate each compound. This is called halide group, acyl rather, acyl group, ACYL, acyl group. This is aldehyde. You have alkanone, otherwise known as ketones, RC1O. This R is a key group which can be a methyl, ethyl, propyl, and so forth, and so on and so forth. Rather, we have carboxylic acid. We have esters R C1O R. This is an alkyl group. This might be different from this. We have this 1, 2, 3, 4. We have 5. Acyl halide R C1O to X, where our X can be X equals to fluorine, chlorine, bromine, and others like that. That is the alkyl group, halide group, halogen group. We have number 6, acid anhydride. RC1O C1O R. These are called the acid anhydride, and last we're talking about amide. It can be called acadamide. So you have R C1O NH2 is an amide. These carbonyl compounds can be divided into two groups. See, class 1. Let's say classes of carbonyl compounds. You have two major classes. Class 1, carbonyl compounds with displaceable substituent. You have class 2, carbonyl compounds with undisplaceable substituent. Disable substituent. So this class 1, they are displaceable. Examples of class 1. We have aldehydes. No. Class 1 displaceable. We have these two are class 2. We have carboxylic acid and its derivative, which are for class 1. We have carboxylic acid, we have esters, we have acyl halide, we have acid anhydride, and lastly we have amides. 1, 2, 3, 4, 5. All these 5, they are displaceable. We have substituents that are displaceable. Then class 2, we have that is a group with the undisplaceable substituent. We have alkana, also known as aldehyde, and we have alkanone. Ketone, they are undisplaceable. The acyl group R C-double-O, it is bonding to this carbon. Let's say this A is alkyl group and hydrogen, so they cannot be easily displaced because they are highly basic. They are very basic. That's the major reason why they cannot be displaced. And based on that, alkyl halides and carbonyl compound generally, we have some that are very reactive and some that are not reactive. We wonder with displacement substituents, they undergo what we call nucleophilic, because this is electrophilic. This working agent will make them to be electrophilic. Carbon being withdrawn, electron being withdrawn from carbon, making this to be polar. This is partially positive, negative, because electrons are moved, undergoing inductive effects. Negative inductive effects because oxygen is more electronegative than carbon, so it's withdrawing electron from carbon. Then this is partially negative while carbon is partially positive. So this point is electrophilic. It needs the electron to balance up. So the carbonyl compounds undergo electrophilic reaction generally. Electrophile will attack. No, nucleophilic will attack. This is an electrophile looking for electrons. So nucleophile will attack rather. I'm sorry. Nucleophile will attack this point. So it will be nucleophilic substitution or nucleophilic addition. The class 1 undergo nucleophilic because they are displaceable substitution, while class 2 undisplaceable will undergo nucleophilic addition. So the activities of this of carbonyl compounds. Like I said earlier, the acyl group RC-double-O, and something is bonded to this place to make different classes of different type of carbonyl compounds. It can be aldehyde, which is hydrogen. It can be ketone, which is alkyl group. It can be carboxylic acid, which is OH. So this is generally A. So the activities depend on what is being bonded to this place. Some are very basic, while some are less basic. The one that are less basic, they are weak base, which is gotten from the strong acid, because the strong acid formate or produce A strong acid will produce a weak conjugate base, which is very displaceable. That is very we will be withdrawing electron towards itself. Like let's say we have a acyl halide. Let's say something we have something like this. R C double one O chlorine. Chlorine is very electronegative and is a very weak base. So basically is how well you can spare. Basicity is how well you can share your electron. So chlorine here being more electronegative, we don't want to share electron with this electrophile here. Electrophile carbon that is positively partially positive because this oxygen is drawing electron from it. So chlorine will not be able to share electron with it. So we prefer to be withdrawing electron to itself. So this is very polar. That is why acyl halide amongst all the carbonyl compounds will be very reactive. Let's see. When chlorine is being displaced here or removed, we have chlorine negative plus hydrogen positive. When this combines together to form its acid, it will form HCl. You know this is a very strong acid. It form a weak base, very weak base. And a weak base, you draw electron towards itself more. Do not share heat like a strong base will do. And the next that is very reactive is carboxylic acid anhydride, R C double O O C double O R. When we look at this, it is R C double O O negative plus hydrogen positive, form something like this, R C double O O H. And we know this is a very strong acid too, ethanol. But mind you, inorganic acid are stronger than organic acid. But this is a very strong acid too, because when it generates electron and proton, hydrogen, it will not be able to come back and join back. So its ability of this hydrogen will not be able to join back. So this compound have the ability to donate proton without the proton being returning back to it through resonance. To resonate, say something like this, negative plus hydrogen. When the hydrogen try to attack there to form OH, it resonates. So it is very difficult for this. So it's a strong acid too. That's why it will form a weak base. This base will prefer to take electron towards itself. Yes. So this is number one. First is very reactive, followed by this number two. The third one there is alkanas. Alkanas RC1O H. This hydrogen here we neither donate nor, because we know hydrogen is having only one electron, it will not want to lose it by leaving or by giving it out. So it's just there. This bond is just there. So it's not donating or withdrawing. So it is just there acting passively. Therefore, this will be very reactive because this polarity is more too compared to what I will donate. I will now lessen the stress of this carbon. This carbon is inconvenient before, but they are still drawing electrons, so they are very reactive to leave, so that this carbon will be covenancy will come to this particular group. That will be covenant with them. When this leave, it will not be covenant with them. Another one to join, which one I will donate electron. So after alkana, ketones are very reactive to the next. Reason being that this is alkyl group. Alkyl group used to undergo what is called positive inductive effect. They are donating electron, making this carbon to be somehow convenient, relieving them of this problem, that is the carbon is being oxygen being withdrawing electron from carbon. It's negative, but this is balancing it back. So it will be reactive, but not as reactive as this, because this is not giving not it's not making the carbon to be convenient, and it's not inconveniencing the carbon, but this is making the carbon to be convenient, so it's less polar compared to this. The next on the table, 1, 2, 3, 4. The next that is very reactive too is carboxylic acid. Carboxylic acid. This OH group two is somehow donating, because this is H2O, OH plus hydrogen, so water. This one too is somehow donating to the carbon, so making it to be convenient too. And followed by the alkoxy group ROH is an alcohol. This one too is donating, making this to be less polar. This is very polar, followed by this, followed by this, followed by this, followed by this, followed by this. So polarity determines the reactivity of a carbonyl compound. Then amides. In other words, these are strong base. They are strong base. They are donating. They are sharing their electron. They are strong base compared to others. This is under a base on an acid. It's not sharing. It's not withdrawing. It's just there like that. So we have carbonyl compounds, amides, R C double O NH2. You know that NH2 is gotten from ammonia, NH3. When it breaks, form NH2 plus and negative and plus hydrogen negative. This is a base already, so it's a very, very strong base. So if you share electron with this and make this to be convenient, so this is the least reactive of all. So 1, 2, 3, 4, 5, 6, 7. This is least reactive of all.